Hey everyone, welcome to Algebra, Section 8.4, Foiling Special Cases. So this is an extension of what we did in Section 8.3 where we learned the double distribution, the FOIL method, the table method. What we're doing now is we're doing special cases of when to use this. So by the end of this lesson, you should be able to identify trinomial squares and use a shortcut to multiply. You also need to be able to identify difference of squares and use a shortcut to multiply that as well. So let's do a quick review. Let's do a quick review of what we did in Section 8.3 with the double distribution. So if I've got x plus 4 times x plus 3, I can break it up and distribute the x to the x plus 3 and distribute the 4 to the x plus 3. So x times x is x squared, x times 3 is 3x, 4 times x is 4x, 4 times 3 is 12. Combine your like terms, and you get x squared plus 7x plus 12. So now, let's go ahead and apply it to something called trinomial squares. Now the reason it's called trinomial squares is because, as you can see in this example, it's written as a perfect square. And you can identify it that way because there's only one set of parentheses with a little exponent on it. Okay? That's how you know how to spot it. So it's a perfect square, and when we're done with it, it's going to be a trinomial. So that's why it's called trinomial squares. I'll also add that it's important that you know how to do this because the next part of the chapter, you're going to have to be able to take something that's the trinomial and be able to write it as just a single set of parentheses with the square on it. So let's talk about how to do it in the first place. So if you have a plus b squared, and I chose a plus b just because a and b can be anything, okay? So if you have anything squared, it literally means that times itself. So a plus b times a plus b. So now what I can do is I can do that double distribution, and I'm going to take the long way of doing this, and let's see if we can spot a shortcut. So I'll split it up, and I'll distribute the a to the a plus b, and then I'll distribute the b to the b plus b, or a plus b. So a times a is a squared. A times b is ab. B times a is ba, or ab. BA, AB, same thing. And then B times B is B squared. So if I take a look, I've got two like terms. I've got AB and AB. Well, if I've got two of them, that means I've got 2AB. So what this says is, if I've got A plus B times itself, I have to square the A term at the beginning, square the B term at the end, and in the middle, I just multiply my A and my B term and then double it up. So let's do an example of that without just letters. Let's do x plus 6 squared. So if we follow this formula kind of like a roadmap, what that tells us is, first thing I do is square the A term. So square the very first thing. So that becomes x squared. Then it says take 2 times your A term times your B term. So I did 2 times x times 6. And then the last part says just take your second term and square it. So 6 squared. So everything's all laid out. All I got to do now is just clean it up a little bit. X squared can stay x squared. 2 times x times 6. Well, the 2 times 6 can be 12. And then 6 squared is 36. So there's my answer. X squared plus 12x plus 36. I would get the exact same answer if I did a plus 6 times a plus 6 and then multiplied them together the long way. Okay? Hopefully you find this as a helpful shortcut. So let's go ahead and do a few examples and see if we can solidify this. Okay, so here we have a worksheet all about doing special cases. So let's identify the ones that we can use the trinomial squares shortcut on. So 1, 2, I can't because it's not in the right format. But if we take a look at question number 3, that's in the right format. It's one set of parentheses with the square on the end. So the formula tells me a squared plus 2ab plus b squared. So that means I will put p squared plus 2 times p times negative 1. And then negative 1 squared. And I put that negative 1 in parentheses so I know to square both the negative and the 1. So now let's clean this up. I've got p squared. 2 times negative 1 is negative 2p. And negative 1 squared is a positive 1. So there's my answer. P squared minus 2p plus 1. Let's do question number 5. Okay, using the exact same formula, so I'll square the x, and then 2 times the x times the negative 4 plus negative 4 squared. Now let's clean it up. 2 times negative 4 is negative 8. And negative 4 squared is, see, negative 4 times negative 4 is a positive 16. There's my answer. And I think that goes a little bit quicker than doing it out the long way using FOIL or the double distribution. Okay, let's do one more just to really nail this. So n plus 3 squared. So I square the n plus 2 times n times 3 plus 3 squared. Clean it up. I get n squared plus 6n plus 9. Final answer. Now I want to do one more. I take back what I said about that being the last example because it can be a little bit more difficult. That's a good one right there, number 23. Negative 9x squared minus 10y squared. Okay, so here we go. I'm going to take the first term, negative 9x squared. A lot in there, so I'm going to put it all in parentheses and know that I have to square it. That's the ugliest 2 I've ever seen. Okay, so that's the first part of it. And then plus 2 times negative 9x squared times negative 10y. That's the second part of our formula. Then plus, take the last term, negative 10y, and square it. So a lot of stuff going on here, and all I've done is just taken those terms and plugged them into our formula. So now let's go through and do one thing at a time. Let's clean it up here. So negative 9 squared is 81. And here we're using our power rule, so we multiply those exponents and get x to the 4th. Now here we've got 3 things multiplying. Let's go ahead and just multiply the coefficients. So 2 times negative 9 times negative 10 is going to be a positive 180. The x squared stay the same. The y stays the same. Well, that one wasn't too bad. And last, let's square the negative 10 and the y. So negative 10 squared is a positive 100. And y squared is y squared. So this problem was ugly, and the answer, actually the answer is pretty ugly too. But 81 x to the 4th, 100 plus 180 x squared y plus 100 y squared. Thank God all the problems aren't going to be like that. Thank God we're going to have some softballs up here, kind of like the ones we did at the beginning. Okay? So now take a look at some of these other problems that we haven't done, like x minus 3 times x plus 3, x minus 5, x plus 5, 8a squared plus 4 times 8a squared minus 4. Do you notice a pattern on how they're all set up? Notice they're the exact same things in the parentheses, except one's a positive and one's a minus. Okay? And that's going to lead us to our next topic, which is difference of squares. So with difference of squares, that's exactly how we're going to identify when to use this. When it's the exact same thing in the parentheses, except one has a plus, one has a minus. So again, I'm using a plus b times a minus b because a and b can be anything. So if we go ahead and I'm going to use the FOIL method on this, and I'm going to work it out the long way and see if you guys can spot a shortcut. So do the first, so a times a, then do the outers, so a times negative b, gives me negative AB. Next, you do the inners, so B times A, which is just AB, a positive AB at that. And then the last, B times negative B. That'll get you a negative B squared. So now that we've got all four terms, let's go ahead and see if we have any like terms. We do. The two middle terms are like terms, which happens quite frequently, but not all the time. So if I've got negative AB plus AB, those two things cancel out. And so my final answer on this is A squared minus B squared. And this is the reason why it's called difference of squares. Difference means to subtract. So it's one perfect square minus another perfect square. Okay? That's what our answer is going to look like. And much like with the trinomial squares, what's going to happen in the future is we're going to be given a problem like this, and we're going to be able to work it out into A plus B times A minus B. Okay? So very important that you get good at what we're doing here so that in the next part of the chapter, you can undo it. So let's do another example with real numbers and see how easy it can be. Because if we back up, the pattern here is that my outer and inner terms end up canceling out. And that will happen 100% of the time. So when I apply that to the next problem, what I'm going to do is I'm going to do the first thing. So 2x times 2x is 4x squared. Now I could do 2x times 3 and then negative 3 times 2x, but I know it's going to cancel out. So why even do it? So let's just move on to the last part. Negative 3 times 3, which is negative 9. So there's my answer. 4x squared minus 9. Now, I bet I know what's going to happen is some people are going to take this shortcut and just do the first things and then just do the last things and totally forget about the outer and inner, the two middle terms. It's fine to do that when it's difference of squares, but if that's the only time it happens. Okay, if it's just a regular FOIL problem, don't forget to do the two middle terms, okay? So let's go ahead and do a few more examples and see how quickly this can go. Okay, so we've already done the ones that are trinomial squares, so we can go ahead and cross those off. We're not going to do those. But we are going to do the ones that are difference of squares, where it's the exact same thing, but one has a plus, one has a minus. So x minus 3 times x plus 3, that we can do. So I'll just do x times x and negative 3 times 3. And my answer should be two things that are perfect squares with the minus sign in the middle. So x squared is a perfect square, 9 is a perfect square, minus sign in the middle, boom, problem done. Let's try another one. X plus 5, or x minus 5 times x plus 5, x times x, negative 5 times 5, boom, there's my answer. Okay, let's try number 10. That one looks particularly tough, but let's do it. So it's the same thing, but one's got a plus, one's got a minus. So I'll do 8a squared times 8a squared, which is 64a to the 4th. And then 4 times negative 4 is negative 16. Hey, that wasn't so bad. Let's do one more just for fun. So 3x minus 7 times 3x plus 7. 3x times 3x is 9x. And then it's negative 7 times 7 is negative 49. Now, hopefully you caught my mistake, because I see students make this a lot. They do 3x times 3x, and they get the 9 part right, but then they don't put the square on the x. Okay? If you don't put that square on there, it's not difference of squares. It's not a perfect square minus another perfect square. Okay? So hopefully these two shortcuts are helpful. And again, they're only shortcuts. If you want to do these the long way, you're certainly welcome to do so. I would rather you do it the long way and get it right than do it the shortcut way and get it wrong. Okay? So if you guys have any questions on this, please feel free to email me. Feel free to ask questions in class. But hopefully this is nice and easy for you. All right, you guys take it easy, and I'll see you real soon.